Hi everyone, welcome back again for another set of workshops in the AI Blueprints Hackathon. Today we have a workshop from the Lilypad team and then another one from the Randamu team. So this is going to be a really interesting one. I'm going to invite our speaker from Lilypad up. Hi Devlin, thanks for joining us.
Hey, thanks.
And we will jump right in. GM. I will hand over to you, Devlin. And feel free to share your screen.
Okay, yeah, let me go ahead and take care of that. I'll share my screen now. All right. So hello everyone. I'm Devlin. I'm Devrel at Lilypad, Lilypad Network. We are trying to provide AI for everyone, make it accessible, basically we are an AI distribution layer. So anyone can create a module to run on our network, create, deploy, and monetize it. And part of our distribution layer is our monetization. So ecosystem that enables resource providers, AI developers to earn rewards for their contributions to our network. Now a module is essentially any compute job, such as AI inference, which is currently our biggest use case, but it's not our only use case. We can do a lot with our network. And essentially anyone can take any open source LLM or create their own from their data and turn it into a Lilypad job module to run on our network, and run that module using someone else's compute, someone else's GPU. So we operate at the intersection of crypto and AI. So anyone can monetize AI models, anyone can monetize idle compute, and anyone can run AI inference or other compute jobs. So I'm gonna give you a quick breakdown of this here. I know it looks confusing. Don't worry. We're going to break it down pretty quickly and pretty simply. So there's a lot that I want to show. I won't spend too much time on this slide here. So for a basic rundown, and if you want to learn more, you can learn more at our docs. The docs are in the top right of every slide, and I'll provide links at the end as well. So if you want more information, there's information on our docs and our website. So to quickly reiterate, we provide monetization ecosystem on top of our decentralized compute network that enables developers such as yourselves to create job modules, such as AI inference via LLMs, and earn rewards for your work when people use them. So this is a diagram of the life cycle of a job request, right? So we're going to start at the top here with the job creators in green, and they're going to access the modules they're going to browse the modules they have access to, and then access the ones that they need. And that could be any type of different jobs, right? And then they're going to choose the one they need, and they're going to send a job request to the solver. And the solver, we're not going to cover too in depth here, but it's basically an internal system that matches job requests with resource offers from our resource providers. It determines which resource providers are going to run which job requests, depending on the estimation of compute required to complete the job. It also handles returning the output back to the original job creator. So after the solver has matched a job request to resource provider, the deal is going to be initiated, and the solver matches the deal with a resource provider, right? So it's kind of two-way here. And then the details about that deal and the result are recorded to our stats API, which I won't cover too in depth here. Doesn't really pertain too much to developers anyway. Again, if you want more information, it's all in the docs, it's all on the website. So the job results are sent back to the original job creator, right over here, back to the job creator. So it goes through access modules, sends the job request to the solver, initiates the deal, payment is sent into escrow. The solver finds a matching resource provider that can provide the compute, and then the deal is made. Job results are sent back to the job creator, and the job creator pays for the job completion. That's essentially this whole workflow here that we're covering. So yeah, that's the basic life cycle of a job request right there. And then here's some. So yeah, I won't be covering our tech stack too in depth here. We just went over some basics in the previous slide. There's a lot that I want to get to, so we're kind of going through it quickly. Again, feel free to ask questions or learn more at our docs, in our Discord, whatever. So basically, we are actually a lot more. So part of our monetization ecosystem is our module marketplace. Now, the official marketplace isn't currently available yet. It is something that we're building, but we do have a collection of modules, both created by the Lilypad team and from some of our community members at this repo here, which I'll share at the end. github.com/lilypadtech/awesome-lilypad. It's a collection of use cases, modules, all sorts of things from the, like I said, the Lilypad team and also our community. And we reward people for creating things on top of Lilypad and adding them to our awesome Lilypad repo of use cases and stuff. So if you're interested in building on Lilypad and you want to get rewarded for your work, make a pull request, check out our bounty board, and do the hackathon. So yeah, and if you want any ideas of examples or use cases that you can do, awesome Lilypad repo is a great place to get some inspiration. So we also provide additional services such as our Inference API, and with additional plans to expand beyond that. But it's an initial offering, and right now I think we've got 10 different models on there, and it's really great. And we've also we've seen some community members and also our internal team members build some applications and stuff on top of the Inference API already. And we just put that a couple weeks ago. Big offering, really excited to have it out. And I'll be demoing that Inference API later today in this demo, in this workshop. So we also have the CLI, good old handy CLI, which we had for a long time, one of our core offerings. It's another way of performing AI inference that we offer for everyone to use, and including module builders. And some model UI interfaces, which we'll go over in a little bit here. But essentially, we've built some interfaces to show potential use cases that can be built. They're not full-fledged solutions, but they are sort of examples so that we hope that community members or people attending hackathons like this one can take those ideas and run with them, create their own full-fledged solutions. So there's a lot of potential here for developers to build their own applications on top. And we also provide module template tooling, such as Create Lilypad module, which I'll also be demoing here today. So we provide 2 different templates, one for Ollama, one for Hugging Face. Ollama is the template that we recommend. It's a lot easier. It's actually very easy to get started with Ollama, building out a module and getting it running on the Lilypad network. Hugging Face is definitely more advanced, and the template could use some improvements for sure. Again, it's open source. If anyone wants to contribute, it's all welcome. However, Hugging Face allows for more also, such as text to image, text to video. Those things aren't currently possible with Ollama. So, for more advanced use cases, you might have to go down that road. But if you can stick to Ollama, if you need a basic just chat LLM, Ollama is perfect. Ollama, it gets you up and running really quickly, and I'll demonstrate that later. And again, there's more examples in both our docs and our awesome Lilypad repo. So we also have some third-party job tooling. This isn't stuff that we provide. These are just resources out there for anyone to use. You might want to take advantage of these yourself when you're building on the Lilypad. Some of our even team members have built agents and stuff using some of these tools, PyTorch, Rivet, Jupyter, Gradio. So these are things that you might want to keep in mind when you're looking to build on top of Lilypad yourself. And then we have our own applications that we've built on top of Lilypad. And I mentioned earlier, these are kind of like the model UI interfaces. We've got a VS Code helper extension recently pushed out by another DevRel, a RAG support agent, so you can provide context from documentation or a website, and it'll provide support for you. Llama 3 chatbot, and tons more examples and use cases in our docs and our awesome Lilypad repo. Definitely check that out. And finally, our resource providers doesn't pertain to developers much, but these are the people that are going to be running your modules, your jobs on the Lilypad network. We've got partnerships with Dell, and including anyone. Essentially, it's an open thing is the idea. So right now we're going through an RP beta program. People have to register to become a resource provider, but eventually we want to enable anyone to monetize their idle compute, become a resource provider on our network. Our solver will automatically match depending on the compute required, and people can get paid off their idle compute. So yeah, I think I'll share some ideas here before we jump into a demo, and I'll probably go over these ideas again. But some ideas for people to get started, to get their brains running: a blockchain analytics agent, a multi-model module, a text-to-image module, text-to-video modules, or any of our examples or use cases in our docs and our repo. Feel free to fork those and build either use them for inspiration or build on top and make them your own. So with that being said, let's jump into a demo. So the first thing I want to show is the Inura API. So if we go to developer resources and Inference API here, I guess I should start off. We're at docs.lilypad.tech. That's the website we're on, docs.lilypad.tech, Inference API. And so this is essentially how you can get started, right? So if we take, we'll just take this. Well, first off, let's go to the Enura website because you'll need an API key. And it's really simple to get your own API key. I've already got one. I'm just going to create a new one for the sake of this demo. And I'll just copy that. And so I'm going to take this whole curl request here. And here we're opening a new terminal. And hopefully you guys can see this okay. I'm going to paste this in. Oops. And I'm going to need to get my API key again.
Devlin, could you zoom in on the
yes.
terminal especially?
Yes. Sorry about that. Thank you.
Thank you.
Okay, so first things first, I'm going to actually change the model here because it's blank. And by the way, this is also the same request that is available on the actual Enura website. If you go to the homepage, this is the same thing that can be copied here, except this one is preset to DeepSeek. But you can set this to any of our available API modules, and I'll show you where to find those available API modules in a second. So let's change the model. We're going to use, for this, we're going to make a small request here. So I'm going to use a small model, Mini 3.8B. Anything else need to be changed? Yes, our API key needs to be changed. I think I already have it copied to my clipboard. Just to be sure, I'll copy it again. Let's delete this and get our API key. Get started. The demo API key right here. And we'll just paste that in, send. So what are we sending? We're sending, anyone that's familiar with OpenAI standard request format will recognize this. We're sending in the name of the model that we're accessing, an array of messages, which we'll go over in a second, and then an optional parameter here or field. So the messages array, this message from the system is totally optional. We're basically providing additional context of letting the model know how we want them to act, or telling them to act like a helpful AI assistant. And then we have a message from the user, which is us. This is essentially our prompt to the LLM saying, what order do frogs belong to? And then the temperature, this is also totally optional. We have a bunch of different optional fields that you can pass in with the request. We're setting the temperature to 0.6 to give a more grounded response. And let's fire this off and send it. So we've got the job ID back, the data, and now we can see that it's processing. It might take a second. And depending on the module that you use, especially when you're building your new modules and running them on our network, so that was quick. It might take a bit longer. That's because, again, you're running this on someone else's GPU, on someone else's computer. They're going to have to download that module before they can run it themselves and provide the results back to you. So first time running a module, or first time running a new module on a new resource provider, it might take a bit longer than you expect. But anyway, we can see here, Enura, they belong to Enura, hence the name of our API. Awesome. So now I'm going to switch to an API client to quickly demonstrate some more of our API a lot quicker than a curl command. This is Bruno, my API client of choice. It's essentially very similar to Postman. People are familiar with Postman. Can I zoom in here? Yes, I can. Sweet. So here we've got a models endpoint. So if you go to /API/v1/models, and this is all on our docs, you can quickly see which models we have available. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we have 10 models available. Just like I said, I was correct. And I think I have all of them on my sidebar here as well, which this collection, anyone that uses Postman or Bruno, these collections are available in our docs. So quickly get started really easily. So Deepscaler is particularly good at math. So we've got this complicated math problem here that we can send a request to. We'll just go ahead and fire that off. And what's cool about the API is it's totally async. So while we're doing that, we can go down to Quen. And this is actually Quen 2.5 coder 7B. So we're going to ask it we're going to ask it a coding question. Solve the advent of code 2022 day 2 in Rust. Boom. And also while that's doing it, we can ask this 5.4 Mini 3.8B again, what is the order of the frog? So all these parallel requests going off at the same time is really cool, actually. And if we go back to Deepscaler, it might take a bit while, especially these prompts are a lot more complicated than the last one we sent, but they're all going to be, processing asynchronously. And look, so as expected, 3.8 mini B, even though we fired it last, actually finished first for multiple reasons. One, it's a really simple request, and two, it's a much smaller module. So we're asking, actually 1.5B is a small module. It's a really complicated question. And 7B also finished pretty quickly, considering we're asking it to solve it in Rust. Not going to go through the process of making sure this is correct or not, but you can tell from looking at the response that if correct or not, at least it tried, right? This is working. Deep Scaler, this is a much more complicated problem. It's going to take them quite a while to solve this, but it shouldn't take too much longer. But yeah, that's our API very quickly. You know, you can use it in the terminal. You can use it with Postman, Bruno. You can use it in your own applications, and that's exactly what you should do. So here's the long response on how to solve that. I don't know math this well, so someone else can fact check Deep Scaler and see if that worked. Sorry. So the last thing that I want to, actually, sorry, not the last thing, but the next thing I want to demo. I'm not sure how good I am on time here. Let's clear this terminal here. Let me actually go to a different directory. Sweet. So now what I want to demo is something called create Lilypad module, and this is essentially a way to quickly bootstrap. Think of create React app, right? But the Lilypad version. So make sure you use this with NPX. This is so that you avoid installing it directly to your machine globally, and so you're always fetching the latest version, because this package gets iterated all the time. It's open source for one thing, so if you want to contribute, you find issues, you find errors, you find improvements, feel free to contribute. We find bug report, feel free to file an issue. We really appreciate that. But it iterates quickly. There's new versions all the time, so make sure you use npx. Create Lilypad module. So this is a really simple way to get started with modules, right? So let's go ahead and fire that off, and we're going to enter the name of our module. You can press enter to have the default Lilypad module, but I have a ton of different modules, so I'm going to name this. We're actually going to do the Gemma 3 model 4B, so it won't take too long. And where am I getting this from? Let me show you where I'm getting this from real quick. Let's open up my browser again, and we're going to go to olama.com. I'm going to zoom in a bit, and we go to models. Gemma is actually a particularly new model and a particularly popular model. So this is the one that we're going to do right now live. And we're going to use a 4B version right here. So let's go back to here. That's the name of my model, Gemma 3 4B. So here you can choose a template. Again, as I said earlier, heavily recommend Olama, especially if you're new to this. The Olama template makes it to where anyone can essentially make their own module. Literally anyone. Hugging Face is a lot more advanced, but it's also for more advanced use cases. So if you're trying to do something advanced, you might need to delve down that road. Again, if you find any improvements or issues with the Hugging Face template, because I'm sure there's plenty to be made there, definitely let us know. We'd appreciate it. But we're going to be using Olama for now. You can type in 1, you can type in O, you can type in Olama. Either one works. Pressing 1 for simplicity. And now let's get started. You can see some instructions here. So just cd into the directory, script/configure, script/build, script/run. And we're going to do that, but we're going to open it up in our editor. I'm using VS Code for this, obviously. You can use whatever you like. Should work just fine. Sweet. So let's do those steps first. So if we open up our terminal inside of VS Code, I'm going to make this a bit smaller. Open up this terminal again. It says to run script/configure first. So I'm just going to copy that and just paste it in here. Nice and easy. So we're going to go through some configuration steps. So the first thing is enter the name that your module will use. And if we look here, that is Gemma 3. So we're going to type in Gemma 3. The version, that is this here. So 4B. 4B. My Docker Hub username is just Devlin Rocha. It needs to be in lowercase, I'm pretty sure. And the name of my Docker image. So Gemma 3-4B, that the default here works fine for me. I'll just press enter. And the GitHub repository. I know we don't currently have a GitHub repository, but we can sort of fake it, right? So github.com. Make sure you don't enter HTTPS as the example shows. Just starting with github.com. Our username, my username in this case, and the name of the module repo. So Gemma, no. Sorry. I'm going to name it Lilypad-Gemma-3-4B. Okay, configuration saved. Now what the terminal say to do next? I know, but just so if you guys don't, it said to do scripts/build. So we've configured the module. Now we need to build it. And now this might take a while. It is a 4 billion parameter module, so hopefully it doesn't take too long. And while it's building, I'm going to sort of go over what makes up a Lilypad module. So starting with our template file, right? Lilypad module json.tmpl. This is actually, to be honest, the only thing that you actually need open source for your module to run. We access this file when we access your repo. This is how we know where to find the model, by using this image field. So we're actually going to replace this now. So Docker Hub username, let's make this Devlin Rocha. The Docker image, I believe we named it Gemma 3-4B, if I'm not mistaken. And the index digest will get this later. So for now, let me go over this here. So what is this file? This file is essentially, and you can find more information on our docs. I won't go over it too in depth. And for most models, the standard TMPL file that Create Lilypad module gives you will be sufficient. But this is essentially telling the solver what resources are required to run your module. So you can see here, we are requiring a GPU, we're requiring 16 gigabytes of memory, the timeout, etc. You can, most of these default settings will be fine. So we won't be covering it too in depth. And if you want, our docs do have more in-depth explanation. But now we'll go over the Docker file, another essential piece of our modules. So you can see that we start from the base Ollama image, and a lot of these settings we're in this template, the Ollama template. A lot of this configuration is according to the best practices that Ollama recommends. So and you'll see that as we go forward. So we set the model ID from the model name and the model version, and as well as the Ollama host, because that's what they ask us to do. We set the working directory. If you've worked with Docker before, this should be pretty common practice to you. If not, we're basically, I won't go over Docker too in depth, but basically we're telling the Docker image that we create that the directory should be the app directory. That's sort of the home root directory of the Docker container. And again, this should be familiar to most. We're just updating and installing the necessary packages and really keeping it as minimal as possible. So for this particular module, we do use curl. Other people like to use JQ and other dependencies. I prefer myself to keep these containers as light and small as possible. So I'm only using curl because that's pretty much essential for Ollama. But yeah, if you need to add anything, you can add it here. And then we even go through the process of just removing anything that isn't absolutely essential. And then we run Ollama in the background and we pull the model that we're using. And then we create a directory for the outputs. Expose 11434 as Ollama recommends. We copy the source code. So this directory here, which we'll go over in a second, this is essentially, this folder will act as the source code of your module. So if you ever change any files in the source code directory, since we're changing it, since we're copying it to our Docker container, when we run these modules, you're not actually running your code, you're running the Docker container. So anything not in the Docker container won't get run. So whenever you change something in your source code, such as this run model file, you'll have to rebuild your Docker image. It's important to keep that in mind. Basically, if anything ever changes in this Docker file, you need to rebuild it, right? If you're changing the model ID, you need to rebuild it. If you're changing the source code, you need to rebuild it, etc. I won't go over too in depth how Docker works. It's a very complicated subject, and we've tried to make it with this package, Create Lilypad module, that you need to know as little Docker as possible. But it does still help, of course. And then that's pretty much it. You can see we set the entry point to be the run module script, which we'll go over right now, basically. So let's jump into there. So the entry point is basically like, again, when you run the Docker container, the entry point is going to be what actually gets ran. So we open up the run model. And again, this is essentially the source code for the module, right? And we're not doing anything too complicated, because this is just the base template, right? You can take this, run with it, customize it, do whatever your module needs to do. But for basic use cases, the default should be sufficient. So what are we doing? Well, first we're making a directory output, right? Pretty obvious. And then we're decoding the request with from base 64. So technically you can remove this, we're sort of mimicking what the Enura API does. The Enura API, our inference API, it automatically encodes all inputs. So I sort of did this to match that behavior, but you can't technically remove this here, and then you wouldn't need to base 64 encode your inputs either. So something you can customize yourself if you want to. And we just start the Ollama server and basically wait for requests to be passed in, right? And this is all stuff from Ollama that they recommend. And then here it is, passing the request just like we did in our terminal, except we're passing that request to the Docker container. And then we're just printing some debug info here if stuff doesn't, if you need to debug anything, really useful debugs here. So yeah, that's pretty much it. Hopefully it doesn't take too much longer to build the module. So I guess while it does that, we can quickly go over what is happening when we run this build command. There's a few different settings here that you can do. So first off, it checks to make sure that you've configured, which we have. We ran script/configure, so we're good. So we didn't get that error message. And again, to make sure that these are all set from the configuration, and they were, so we're good. Then it checks for flags. So you can actually pass in a local flag to build the Docker image locally and run it locally. So all these modules can be built and ran locally, just like they can be built and pushed to Docker Hub and ran on Lilypad network. In this demo, we're going to actually run them on Lilypad network, not locally. But if you wanted to do any testing locally or just run these yourself locally, technically you can do that. So yeah, we didn't pass in the local flag, so we're pushing this to Docker Hub. And we also have major, minor, and patch. So if you check our env, this actually got created when we ran configure, or filled in rather. It was already created, but it filled in the values. We start with version 0.0.0. So if you pass in the build, if you pass in the patch flag with the build command, for example, it'll increment this to 0.1. Minor will increment the second one, and major will increment the first one, as you'd expect from Semver, right? And that's pretty much it for the most part. Then we go down. You also have the no cache flag. You shouldn't need to use that, but we provided it just in case people are having issues. And then that's it. So basically, if you do pass in the local flag when you build, we'll detect your system and use your system. Unless you're on an unsupported system, then it gives an error. But otherwise, if you're pushing to Docker Hub, it'll automatically set the platform to AMD 64, which we support. And so you should be good. You shouldn't have to worry about anything. And you can do this yourself. You don't need the script/build, right? You can technically just run Docker X build, and pass in these things yourself. We're just trying to make it easier for people, especially people that aren't used to working with Docker. And that's all that this script really does. The configure script, you don't really need to go over. This really just asks questions and sets the things. And the run script will go over when it's time to run. I think maybe for now, we leave this building. Hopefully it's on the last step, so it shouldn't take too much longer. Maybe for now we leave this and come back to it in a little bit. How am I on time? Is there a time anywhere? I don't know where to access the time.
You are all good on time. There's 15 minutes until the end of your section. If you need a bit longer, that's absolutely fine too.
Okay, perfect. Yeah, I shouldn't need. It's cool. So let me go over this very final.
I'm so sorry. I've just moved you off the stage. Please bear with me a second. What have I just done? Devlin, hang on a second, because I've moved you off stage, but I can't invite you back up. Can people confirm in chat if they can still see Devlin? I think this is a live storm problem. Oh no, I'm so sorry. It still says Devlin is on stage, but it clearly isn't. This is the second live storm disaster I've had today. Devlin has... I can invite him back. I'm so sorry, guys. It's nothing against Devlin, I promise. I'm so sorry.
No worries, no worries. It looks like we figured it out. We're back.
Do you want to share your screen again?
Sweet. Okay. Yeah, so looks like while that technical mishap was happening, we actually did finish building. So let's go ahead and go over this. So we're presented with a final set of steps here when we finish building. So the first is to visit the URL right here. So we're going to do that. And this is going to be, it should take us to our Docker Hub image. If all goes well. Perfect. Now, what you want from here, this actually takes you to the specific tag that you built. So you were on v0.0.0, and you can see all the tags for our repo are here. But we should only have the one. Well, and latest, right? If you want to use latest, but we're going to use v0. And what you want from here is the index digest. So just copy this and move this over. We're going to open our TMPL file, and we're just going to paste it here on our index digest. Boom. Perfect. And that's actually good to go. So there is actually one final step, and that is creating the repo for this. So let's do that final step, and then we can actually run this on, I'm not sure why the internet's taking so long. And then we can actually run this on the Lilypad network, which is really exciting if GitHub would load. If GitHub would load. And hopefully GitHub's not down because I need GitHub for the next portion, the oncologist AI agent demo. Let me try a new tab. Uh-oh. Okay. Let me try a new browser. Let me try opening this in Chrome real quick. Okay, Chrome is working, so it must be just an issue with Firefox/Zen here. Very, very common to have issues with Firefox. So let me pull this up. Let me go to my repositories. He brought GitHub down. Yes. First, you can. Yeah. Okay. Devlin Rocha. So let's make this match. Yeah. Lilypad Gemma 3 4B. I guess I can't copy that here. So let's Lilypad Gemma -3-4B. And yeah, we can leave everything else everything else alone. And we're just going to add the origin here. Go back to our VS Code. Oh, and we need to obviously commit it all. That should be fine. Okay, copy and paste, boom. And here's all of our stuff. Now we can just take this here. Actually, there's multiple ways we can do this, right? So we'll show you the simple way first. Now, if you're gonna run jobs in our CLI and not use our API, for you there will be an extra step required. If you go to getting started here, this will tell you how to use our CLI. So first you'll need to install our CLI, and then you'll need to set up a wallet. I've already got these steps figured out. And if you need help, we actually do have a video on our YouTube on how to do this in 5 minutes or less. It's really quite simple. I just don't want to spend the time to do that right now. I've already got it configured. So we're going to jump back into here real quick. I'm going to move this terminal off screen for a moment while I set my private key, because you will need to pass in your wallet private key. Sweet. Now that's done. Let me bring it back up to the main screen. Same repo, nothing's changed except for the terminal's been cleared. And so let's type in scripts/run. So here it's providing us a template for our request. So we're just going to copy this template and we're going to paste it as one line. And we're just going to send it as is. This is fine. It's asking the same question as before, sort of our default question. What is the order the frogs belong to? What is the order of the frog? And while that's running, I'm going to show you how we can also do this without running the script/run command, because you don't need to access your repo to run this. Now that it's deployed, anyone that has the Lilypad CLI installed, which is so cool, can run your module. Literally anyone. So if we go to the README, we can take this sort of example here, paste it. Oh, I will need to set my private key in this terminal real quick. Give me 1 second. Okay, bring it right back up. And so the only thing we'll need to change are, of course, the default parameters. So we'll pass in the repo to our the link to our repo. Was it Lilypad-Gemma-3-4B, and our tag. So our tag here is actually going to be the commit SHA. So if I just open up a new terminal here, type in git log, we can easily find our commit SHA right here. Paste that in. The model name. Oops. Forgot highlighting doesn't work in the terminal. Was it Gemma 3 or Gemma -3? I think it's just Gemma 3. And the version is 4B. So you can see the request finished in the terminal there in VS Code, but we're also going to run it here in this terminal to show that anyone, you don't need the repo available, anyone can run your module on our network once it's pushed to GitHub and is compatible, right? So while it does that, let's open this one. So we're going to take this first command, open, and we're going to paste that. Outputs, response. And there's our response right there. I don't know why I opened in Firefox. I have too many browsers on this computer. But here, let me make it bigger so you guys can read it properly. But yeah, it's classification of frogs. And where's Anura? Looking for Anura. Anura within Anura. There it is. So, you can read the full response, but it's basically gave us what we're looking for. And the same exact thing is going to happen in this terminal here. So we'll give it a second to run, but essentially that's building a module and running it on Lilypad network. So for the last thing we want to show is an agent that we have that we've recently made. Again, these are all in our use cases in our docs. The agent I'm going over is actually this one here, our AI oncologist agent. You can find we have a video on it here available. We have the GitHub source code available, which is where we're going to be visiting. Boom. So you can check all this stuff out yourself on your own time as well if you like or if you missed anything. And boom, perfect timing. Here's this result. Should be a very similar answer. We asked it the same question. Should maybe ask it something different. But there it is. Two different responses. Yeah, see this. But yeah, slightly different. Should be similar. It's a bit more complex than just saying frog. It's a bit more complex than just saying frogs. So there is a difference in the answers. They're just very slight. All right, moving on. Good stuff. So this is our AI oncologist agent. It essentially has 3 different agents that it goes through. Paper relevance agent, which searches and identifies research papers. The top paragraphs agent, which then ranks those paragraphs from the selected papers on what is most relevant. And then the text query agent analyzes those paragraphs provided and gives focused answers to those specific queries. And it can do tons of other things like generate protein models, 3D models, PBB files, all sorts of really cool use cases for this. So let's jump into it. I've already cloned the repository, but if you want to run this yourself locally, you can. Let me just pull up the GitHub repo here. We'll pull them up side by side. Oh, wrong one. I have it open here. Here's our AI oncologist. And we'll make this a bit bigger for you guys, or a lot bigger. Okay, perfect. So we can just close that README so it's not confusing. So I've already installed the required packages. It doesn't take long, but you can do this yourself. It's just at the end of my time, so maybe going very quickly here. Nice try, Force. So we've already created an env file. I won't show you mine because it has my DeepSeek API keys in there with some credits in there that I don't want y'all to use. So basically, we're just going to run straight to the part where we use it. So let's just run this command, python aoncologist.py. Use it here. Hopefully it goes smoothly. It may take a while, but I just want to reiterate again. I'm going to keep reiterating. Our docs have all these use cases for you to explore more in depth, for you to learn about more in depth. I'm just trying to provide sort of a multitude of options here to hopefully inspire people to come up with their own ideas, their own use cases, to keep building on top of Lilypad, whether that be their own unique ideas or something that we've already sort of built and they want to flesh out upon. There's tons of stuff that you can do with Lilypad. And that's really the point of this, is to show some of those use cases. There's really so many. And even what I'm showing here is really is AI focused, obviously, but there's really so much you can do. So yeah, while this runs, I guess I can give you some more. We can reiterate, right? So if you're looking for ideas, if you want to build an agent, a blockchain analytics agent, anything that sort of reads data from the blockchain and analyzes it would be fantastic. A multi-model module. So a single module is able to access multiple LLMs. Fantastic use case for us to have. Text to image models and text to video modules. We currently do have an SDXL image model in our docs if you want to use that as inspiration and keep fleshing out. And we used to have a video module as well. I think that's I don't think we currently support that right now. So if you want to make a text to video, that would also be fantastic. And again, you can find these examples in our docs, fork them, use them for inspiration, whatever you want to do. This is still running. So I guess I'll just go, our social.
While that's running, we actually have a couple of questions in chat.
Perfect. Okay, yeah, we can get to the questions.
So I'm not sure if you're able to see, but in the questions tab, first of all, Rolling asked earlier, from what I saw, it looks like all the inference models are LLM, and you mentioned it earlier. We can build a module for a non-LLM model, though. I think they're asking, could you build a module that's not an LLM, just any sort of AI model?
Yes, you absolutely can. For our API, we only have LLM models. Our API is also a fairly new release. And so we're currently focused on supporting the top LLM on the API, but we do plan on expanding that with more. And again, if you want to create your own modules, it can be quite literally anything. It doesn't need to be an LLM. Doesn't need to be AI. Even our Hello World example that we use for our CLI is we call a cow say. It's literally just prints a terminal output of a cow saying whatever you prompt it to. So it can be any compute job. Doesn't need to be an AI. Doesn't need to be LLM.
Okay, well that's actually interesting because the second part of Roland's question was, would modules be useful, but would Lilypad network be useful for decentralized training or inference only? So I think they're talking about training models rather than.
Right. Yeah. We're mostly prioritizing inference. I don't think it's possible to train on Lilypad network. I could be wrong, but I know that's also not our focus. We are mainly focused on providing AI inference for everyone, whether they want to run the module, provide the module, or provide compute for the module. We're mainly focused on inference.
Okay, that's really useful. Thank you. And Mohammed has asked, can you talk a bit about fees and monetization? It's not clear how we determine how much a job costs and how much runners will earn. Thank you.
Right. That's an excellent question, Mohammed. It's actually something we haven't fully developed yet. It's actually our engineers. It's one of the top things that we're working on before mainnet and before TGE. There's all sorts of engineering questions that go into that. I can't really provide a concrete answer. What I can tell you is that currently, right now, as of today, everything is currently free. There is to run, right? So LP tokens, if you want to use our CLI, are free. You just need to get them from our faucet, which is free. And if you want to use our Anura API keys are free, and we currently require no credits or nothing, no wallet to run the API whatsoever. So that's all currently free. Module builders will still get rewarded based off our bounty board and based off this hackathon rewards. So there are still rewards in place, but the whole module marketplace and monetization ecosystem that we want to enable is still a work in progress. Some pieces are there, some pieces are still being developed, but the whole puzzle isn't quite there yet.
Okay, awesome. Mohammed followed up saying, thank you, that's awesome. So I think that answers this question really well. Those are the two questions that are in the questions tab, but if we do have a couple more minutes while the terminal is still running, did it finish actually?
Yeah, sweet. So it looks like here's the output real quickly of the AI oncologist. I'll show this really quickly. We do have a Discord. I'll show you the link to that in a second. So here's the latest developments in lung cancer based on the provided text passages. And we won't read all these over, but is essentially read through these documents that we provide here, and it ran the prompts that we provided it. So again, if you want to learn more in our docs.
Never mind. I think your mic went a little bit funny there for about 10 seconds, but it's all good now.
I'm sorry about that. But yeah, it's in our docs. It's in our use cases. This agent is really cool. We just put out an awesome video showcasing it way more in depth if you want to learn about it. It's about 20 minutes long in our docs. So here's some of our links on, I should say links, not socials, but whatever. Docs@lilypad.tech, our Twitter, and our Discord is all available here. I'll put the links in the chat. Give me 1 second.
I think Sam has already posted the Discord link.
Oh, sweet.
So the
Perfect. And here is also the awesome Lilypad repo if anyone wants to check out our examples and use cases. There you go. And I think, yeah, that's my final slide. That's it from me. Thank you, Rebecca. Thank you, audience. Thank you, everyone. I appreciate it. Looking forward to what y'all build on Lilypad. Really looking forward to it.